what, yeah.
Could you also send us like all the links, because I didn't get any, like, and to like the very last article you were just going through like right now, maybe it'll be good.
Yeah, I can share it with you. It's not the last version. And the problem is that it's not published, so I can share a doc with you, but it will be like, I don't know how can I do.
Maybe there is something else we could read, like something like this on Andic languages, or is it like the only existing?
No. I will send you a PDF. I think it's better to have as a PDF version of this. Let's think what I need to send you. It's actually a lot of things that I need to send you. So open with save file or desktop, for instance. First, have I shared the Andic folder with you?
I don't think so.
This is,
But maybe I'm wrong. Do you remember, Wanshu?
I think maybe we just got the doc or something, just the one file, not the folder.
I definitely got the Excel file, like with like all those tables, like maybe it was the same file, but just like the earlier version.
No.
For some
What
reason
I'm
you
calling,
sent to,
this is a little bit complicated
but I
for
think it's the only
Wanshu,
file, and plus some literature.
because I have something like the whole folder about Andic languages. Probably I'll do just like this, and then in several hours we'll get something there. Oh no, maybe this is a bad idea because I'm leaving. Okay, maybe then I will just drop it again and it will be there. Okay, so maybe it will be even uploaded. So here we have this, and then I need to share it with you.
So these are dictionaries, right?
No, this is all I have on Andic languages,
Oh, like everything.
like grammars.
Oh, okay. And we might need to go through some grammars as well, right?
Yeah, it's possible that you'll have this need. Google Drive folder. Desktop. Andic draft. Not share.
Okay.
Do you need this article on? I don't think that you need this article on different genealogies, about genealogy of Andic languages. But maybe the thing you need is something like this screen. But this is also misleading because this, oh, why it's twice. Don't need you anymore. Okay, so this is a little bit misleading because Tatmagit is a village. So you somehow need to know that Tatmagit and Rutlub are Ahwah villages and so on. So this is like a bit complicated, but I guess you won't need this so detailed information. Okay.
And also the link to your web page with all the like stuff for us, like preparation.
This preparation. Yeah. Mm. So do you have equipped feeling? I hope
Wow.
so. Okay, so let's move on with my preparation. So after this, you'll have something like this data set inside R, like over here. And probably don't need this.
And these numbers, they are the entries of like the number of words for each language, right?
What kind of numbers? So
Like
this number
to your like RStudio window, like back to it.
in my over here.
Yeah, so these are languages like where you are.
Yes, yes.
Where,
But this is like maybe it's better to count. So it makes sense to count it differently because now we have the repetition of different words. So it maybe makes sense to do something like distinct lemma, then count like that. What's happened? Is not found. Okay, you're right, mate. So here is the better number. So as you see, so for instance, there is some, yeah. So we have 9 varieties that are actually 8 languages. So this is Glotto code. So this is like so this is code from this Glottolog over here. So for instance, Hachvach have Glottolog Ach 12 and 39. And each language has its own code. And instead of language names, I use these Glottolog codes because it's easier. So we have this Tukita, a dialect that actually dialect of Croata. Of Karata. And everything else is more or less separate language. So language, 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 yes. So all others are separate language. And this is make a result. So for instance, for Tukita, then so it grasped from the dictionary. So you will get something like 212 words because it's in the dictionary of Karata language. And when you have form that in dialect we have this form, then we have this Tukita form. Because we can't assume that all forms when we don't have this kind of notion are actually the same or not. So Tukita is a little bit, yes, and another thing. This is also a problem. Source and source. Because for Botlich, how do I call it? Okay, how do you call it? Reference or what? Reference, okay. And I'll do this. So another problem that you can find that there are actually 2 dictionaries of Botlich there. And you need to take care about of it. And actually ignore it. And this is a mistake. I need to redo everything with having this in mind.
like, what do you mean? What do you mean by ignore it? Which, like, are we supposed to ignore one of the dictionaries or what?
No. I ignore this distinction. And when I created all plots, I ignored this. It wasn't so. Now I think that is a mistake, so I need to correct it. It's not like you need to do the same. Okay.
Okay.
Maybe unnested index still had it. No, it's not. Uh, Here. Reference. And maybe after this. Watermark. Maybe I will do the trick. So we'll do it like this. So mutate glot code equal strc glot reference glot code reference. And then we can leave with the old version. So now I took care about the. This is weird. Maybe we need to add space here. How many botlich we have? We don't. Okay. It's not a problem because botlich is not transliterated here. But yeah, in the future it will be a problem. Okay. So maybe I will update it over here. Hope that it will change. So for instance, source is here. It will be updated in a while. So let's go to the entire web. So here we read, and so do you have any questions about the structure of the table? So do you remember those IDs, what they stand for, and so on and so on?
So the word, the meaning, its ID, then lemma, then like phonetic something, like how it sounds, right?
Yeah, so this is lemma.
Yeah.
This is IP transcription of it. Then some morphological information.
Does it mean that this NA thing that R can't understand what it is, like what the phonetic, like what the transcription is, right?
Yes, it does. I didn't get the question actually. So here, for instance, NA means that there is no, so it's empty value over there, but there are languages that do have it.
Okay.
So this is raw information that been there. And don't think that this column can't have any mistakes. It's possible that there are some mistakes over there.
But this is a column that we will need, right? This is like
yes.
And R can't really read it. What?
Why? It can.
Or it can.
It's there. Here it is. Can't you see it?
Yes, but I didn't get why. Like, if you go back to like the page, like web page.
Here, there's an A over there. Yeah. Why?
Yeah.
This
why is it there?
Because we don't have because this is my work and I didn't finish it yet to transliterate everything for you. This is
Okay.
just, it's not done, so it's not. So for several languages, it's not just done. I didn't manage to do it. So it's Godaberry and Botlich and maybe something else.
Okay, I see. So not like all the raws have it.
Yes, not all languages are transliterated, but I will do it in a while.
Yeah, I get it now. Yeah, thank you.
Cool. So this is important column because it's boring. So whether something is borrowing or not, and you have an A if it's not borrowing, or actually we can. So actually, it's better to formulate this way. We have one if it's clearly the borrowing. Does it work? Oh, okay, it worked like this. Then annotator. This is the person. Part of speech. Concepticon is connection to another database, but we, for a moment, we skip this step and nobody will doing this for now, but we'll continue. Then meaning in Russian, and this is one we try to formulate it as minimum as possible because in most cases the definition contains a lot of information, and this is just a small extraction of this information. And this should be different for different meaning ID. So first meaning is никогда, is never, and ни за что, so for no reason. How do you say? I would have never do this or something like this. And then we have definition. This is like extraction from the dictionary, glottocode, reference, some comments of different people, borrowing source words. So there, it should be unified, but for now there is, for some languages, there is data about the source of the borrowings of, instance, Arabic, Russian, or Avar, or something like this, or Persian. And so on. So this is the whole data set we can play around. Okay. And afterward, actually, I start this piping structure. Do you understand pipes?
Yes.
Cool. So the one thing particular, maybe Vanya, you had classes with Vanya, and he don't he used another strategy, but I like to finish my pipes with this arrow. That means the everything that is gathered from this pipe is go here, assigned here. So the most common tactic here, what you can see will be different. So it will look like this. So you move this away and you do something like this. So this is the most common pattern that you will see. So it looks like this. But I prefer to do it like in different way because I think it's logical, but it doesn't matter. Okay, so we have this ending, and then I do the filter is NA borrowing. So I filter those values that do have NA in the borrowing column over here. Then I use distinct IPA and glottocode. So they are actually split into, there are multiple repetition, and this distinct feature will return the unique combination of IPA and glottocode. And maybe I can write, yeah, if I rerun it. So now it's updated. So over here I have this mutate that combines glottal code with the reference, and it will make it possible to avoid the problems with different sources. Okay. So here we have different IPA and glottal code. So for each language, we have unique IPA. And after this, I create an ID for everything that was created, because this ID is, it's possible to use this ID actually, but for some reason I decided to use a new one. So I create a new ID that go through the whole data set and then parse it and you have a value for each row is have its new ID. And then I use unless tokens function. And this is function from this tidy text. Oh, no. Stay on page, please. Oh, it's actually like doing really, really well. It's nice. So sorry. So this function unless tokens from the tidy text package, where I put the output. It's the new column that I'm creating, and input is column that it takes to split to. And then there is some arguments that help me actually convert this about that into table when we have every segment is separated into the new row. So for instance, here we have this unnested ANDIC, and in the glimpse, you see that there is ID, and here is A, so the first word is A. This is Chamala word, and there is ID 4, and then there is the segment A, or A, and then we have next word, AB, that is probably also Chamala word, and then we have A and the next row, so the word is repeated, and this is B. Maybe glimpse is not nice way to show it. Maybe I just show it here. So here we have, the first word, and then there is multiple repetition of the second word because we have different segments, and they are listed in the as a separate column. So in the separate row, sorry. So A, B, and then something R with this strange stress, B, and A, ba, da, and so on. So this is one word, and that's why we have the same ID for this word. It's 6, and everything else is repeating. And this is called long format. Maybe it's possible that you spend some time with Vanya talking about long format, aren't you?
I am not sure.
Do you use pivot longer or pivot wider function? Or pivot wider pivot, I would say.
I can't recall that. I mean, I'm not sure.
Okay. So anyhow, this is kind of structure. So this is kind of structure that's called tidy structure or tidy data. That's why all these packages that I used have this tidy prefix. So tidy words, tidy text, and so on and so on. And the idea that each observation is one, you have one observation per row. So here we have the first segment, second. So here's the first segment of the next word, second segment of the next word, and so on and so on and so on. And it's really easy to grasp and manipulate those kind of things. That's why I use it. So getting back, after this, we have this structure, and we can extract singleton frequency because what we want is just calculate frequency. So here we have. So we group by language by this one, by glottocode, and then we calculate frequency of this word. And this is like simple operation that could be done. So I count glottocode and segment. Then I group by glottocode and create a so I create a new variable that I call overall. So this is like sum of all iterations that I have. And after this, I calculate ratio when I have n divided by overall. And after this, here it is. So here are some results. So for instance, in Ahlach, we have vowel A, and it appeared in our dictionary 7,629 times. The overall, so this is number of different segments in the whole dictionary. So 53,000 of them. And this is ratio. So this is scientific notation. So it actually says something like this number, but divided by 10. So it's actually 0.1414 and so on and so on. And this is much smaller because it's divided not by 10. So here is the 10, and here is the 1000 because it's divided by 10 multiplied in the
by 10 and by 10.
3 exponent. So this is actually explanation. So yeah. So this is smaller number, much smaller. And this number is in the middle. Okay. And after this, we can look at it. So here is the values. We could actually go somewhere in the deep ocean, let's say. An A here denotes that, so I use this pivot wider function that, because now it's like really long and it's not viewable by people. It's hard to read if you're a person. But here I have one segment per row, and then I have one language per column. So here we have multiple languages, and we have frequency for each segment. And if you have NA, that means that we don't have such a segment in the dictionary. Something like Shwa is present in Ahwah, but it's not present in Bagwalaw, for instance, at all. We can actually replace it with 0, but it will be maybe a little bit fishy. So it's easy to do, but I don't know whether we need it. Oh, I see a mistake over here. Yeah. When we have no, maybe it's not a mistake. No, it's a mistake. So it's better to use na.rem go to because of this. Yeah, okay. So the rest is fine. Okay, so after this, we can even visualize it a bit. So we have this segment frequency, we group by segment. And this part is also, is actually made in order to make it fancy looking. Because what I want is to sort according to the mean ratio of each segment in different languages. So over here, what I'm doing, I'm regrouping it in that way that you can do this. So I group by segment, then I mutate and create a new variable that's called mean ratio. So within each group, so within each segment, I calculate mean value for these dots, for instance. And then I use this in order to change our segment. So I order the segment according to this new variable. And now we have R have highest mean ratio, then we have E and so on and so on. So we have this declining ratio. And then I use stop and 100 because I wanted to select something like 100 dots and plot them. Yeah, and then the rest is simple. So ggplot, aesthetic ratio is X, segment is Y, color is glottic code, jump point is the way of visualization. So here you have it. It's not so like saying a lot, but we can look there and see what's going on. And another thing, it's possible to sort it. Maybe this is squishing is not well, doing not well for. Maybe we can do this. I can remember. It's easy to do like this. For instance, 5, maybe 6. Maybe this will make it better. This is because of this long. Yes, This is because of this long legend that I have. Maybe I can read of it.
I'm confused. What are you doing right now?
Sorry, I'm changing the code in order to. Maybe I will change it later.
Aren't
Okay.
we supposed to let you go at 3?
Sorry.
Aren't we supposed to let you go at 3 p.m.?
It would be fun, but I have little to say more. So
Oh, okay.
something like. So blah, blah. So first you can face a trap, so you can split it into different languages over here. And you also can do is to use this line over here because it's just repetition. Yeah, so I use this line in order to filter vowels and non-vowels. So for instance, here I have str detect segment, this one. And this is really nice trick because str detect is actually detecting whether you have this symbol in the string. So for instance, if you have E with, I don't know, with some stress or asterisk or something else, then it will say true to this. So that's how I filter out all vowels. And then I'm making more or less the same plots for each vowel. As you see, I is frequent everywhere. But the second vowel is different. So for instance, here is E, then here is U, E, air, even air. This is strange, but this is actually underlying historical changes that is playing there. But it's nice to see them in this one. Okay. And in order to make consonants, you can do here. So there's the difference between this code and this code is just one design. And that's making filter out those that are not vowels, that are definitely consonants. And here we have the most common consonants is R, 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 L, and B over here. Oh, this is brilliant. But Turkita is not representative at all. But this is the result is really nice. Okay. And then we have the next part that I actually didn't finish. So probably we'll discuss this part, but then I will write a code for doing this. So since our work is about detecting different coincidence in different frequencies, it's actually, we need to extract information about combined frequency in the same word. So within each word, we want to calculate what kind of sounds are present, like in pairs. And there are two ways of combination of combined segment frequency calculation. Maybe here I just put it here, so we don't need any visual interface for this. So imagine that we have word, I don't know, abadat, for instance. We can calculate what is the frequency of A and B being in the same word through the whole dictionary. And this will be the first option. So abadat, then we need to have something like a, b, I is repeated, so we don't care, the, and tl. So we have 4 sounds and we need to make all pairs of those sounds. So this, and this, and then put it in the table. So
Why don't we care about the second R?
because what we try to estimate is the probability of 2 sounds to be in the same word.
Okay, but I thought that our like measurement was not a word but a syllable. No? Oh,
Then
like
it's impossible to. First, I don't care
okay.
because it's possible to do with syllables and compare. Second, it will be strange work for vowels because in vowels you have one
Yeah,
vowel
yeah.
per syllable, so that would be strange.
Mhm.
Yeah, something like this. So yeah, so there are two possible ways of doing things. So what I expect from you is actually I will write more or less general algorithm that don't cares about whether it's working with consonants or vowels, but it makes sense to remove, for instance, when you work on your separate topics, it makes sense to remove vowels or consonants depending on the topic. So I started that it's possible to, so first we try to calculate so one way is try to estimate what is the probability to see two sounds in the same word or a syllable or whatever. And then compare this to the original frequencies of the segments. And the second strategy, I really didn't thought about this when when we talked before, but there is also there is a way to do it like in more like Markov chain way. So you see, so you choose the type of the units that you work with. So for instance, it will be consonants or vowels. And then what you try to predict is what is the probability to have this vowel after this vowel, or these consonants after these consonants. Oh, sorry, this consonant after this consonant. Uh, and then you calculate so all kind of steps. And this is like a little bit like in Markov chain style because you try to predict the next state based on the previous one. I think those are two possibilities to analyze this data. And I will write a code to do this.
Okay, it makes sense. Like both options make sense to me.
Okay. So do you have any questions so far?
I might have later, but not right now.
Wanshu?
Me too. I need to go through the steps and then maybe I will have.
Okay, maybe you both overwhelmed with the complex code that I threw on you, and maybe it makes sense for you because for now, I think it makes sense to you just more or less go through the code and try to understand what's going on where. Uh, and because since those are pipes, it's possible to split. So remove the pipe and then you see the output. And then you'll see which line do what. So I think for the next, is this time actually suits you both? Because it's possible to make an appointment for the next week.
I think so.
Wanshu?
Yeah.
Great. So maybe then let's meet on the next week, and you try to play around with the code and try to replicate everything and try to whether you have any questions about the code. In the meantime, I will try to finish my part. So there are two tasks that I should do before you start working. First one is to finish the code for two methods that I mentioned. And the second is actually to provide transcription to Godobry and Botlich. So those are my tasks for the next time. Okay.
Okay.
So the next time you start playing around, and then we'll discuss the next steps and how do we do this with code and what our ideas on it. Okay.
Okay.
So it's nice to see you both. Sorry for a little bit delay. I get overwhelmed with different things, but now I'm okay, and we can meet more or less every week and do small things until we do great things. Okay. So don't hesitate to write me if you have any questions. And see you next something tomorrow. We have
Next,
class tomorrow.
yeah, tomorrow. Yeah.
So see you
Tomorrow.
tomorrow.
Yeah, thank you very much. I'm sorry, my phone just died, so my camera's off. But
Oh no.
yeah.
Okay.
Yeah.
So have
Thank you
a
all.
nice evening,
You too.
and whatever Wanshu is having there. Maybe it should be.
No, I'm in Moscow now.
Ah, you're in Moscow. Okay, cool. So we have the same time. That's good. Okay.
Mm,
So bye.
bye bye.
Bye.